All right, today we're diving into a new kind of AI that's being trained to do something, well, something pretty radical. It's not just about playing the stock market anymore. This is about asking an AI to discover the fundamental rules that govern it. Like the financial laws of physics.
But to really get why that's such a massive leap, you got to look at how things are right now. See, most financial AI today is all about reacting. It scans headlines, it judges the mood of the market, and then it places a bet. But what if we could ask it to do something way, way deeper?
And that right there, that's the core idea. We're not talking about an AI that just plays the game better. We're talking about an AI that can figure out the rules of the game itself, the actual mathematical models that describe how the market behaves. Okay, so here's the plan. We'll start with what's holding current AI back, then we'll dig into this new approach. We'll look at how it actually works, how they tested it, and what it all means in the end. Let's get started.
First up, let's set the scene. Before we can talk about the future, we need to get a handle on the present. What's the problem with the AI traders we're using right now?
Large language models are amazing at what they do. They can read a mountain of news articles and get a feel for the market's mood. Is it optimistic? Is it fearful? But here's the thing. When you're talking about finance, that kind of sentiment analysis, it's really just scratching the surface. It doesn't get into the deep, complex math of it all. And that leads us to the crucial missing piece. The researchers call it a principled model building step. That's a fancy way of saying the ability to create real mathematical models from scratch. We're talking about going way beyond just reading text and actually building the complex equations that can truly capture how a stock might behave. Okay, so this is where things get really interesting. This is the big shift. Instead of just feeding an AI information and asking it to analyze it, these researchers gave it a whole new job description: to become a discoverer of financial models. What they built is called an agentic system. The best way to think about it is like a dream team of specialized AI agents, all working together. And their goal? It isn't just to recommend a trade. No, it's way bigger than that. It's to build and improve the very mathematical tools you need to even understand market risk in the first place. And here's a look at the blueprint for this whole system. You've got your AI agents looking at news and historical data, which is pretty standard. But the real game changer is that automated model R&D block right there in the middle. Think of it as an engine whose only job is to discover and build new models. That engine then gives crucial risk info to the final trader agent, which is the one actually making the decisions.
So you're probably wondering, how does this automated model R&D thing actually work? Well, the secret is basically a classic creative process, like you'd see with humans, except this one is run entirely by AI.
They call it the builder-critic loop, and it's brilliant. It's like having an AI scientist and an AI peer reviewer working side by side. One agent, the builder, takes a financial model and actually writes the code to test it out. Then another agent, the critic, comes in, looks at the results and says, not bad, but here's how we could make it better. It suggests improvements, and the whole cycle starts over. And it's this really elegant, non-stop cycle. First, the critic chooses a model to test. Then, the builder actually builds it, writing the code. After that, the system calibrates it using historical data and runs a simulation to see how well it works. Finally, based on how that went, the critic suggests a new, improved model, and boom, the loop starts all over again.
And if you really want to see the nitty-gritty, you can see here just how detailed this whole feedback process is. The builder agents, those are the ones in the dash boxes, are the doers, the coders. And the critic agents in the dotted boxes are the thinkers, the evaluators. It's basically a constant automated conversation between them, all in the service of finding the absolute best model possible.
So let's just pause for a second and really nail down the difference. Your standard AI, it analyzes information. It uses the tools you give it. But this agentic AI, it creates brand new analytical models. It's not just using the tools you see, it's literally building the entire toolbox from scratch. Okay, so building a clever AI system is one thing, but proving it actually works, especially in the world of finance where the stakes are so high, that's a whole different ballgame. And this brings up a really tough problem. Think about it. These big AI models have been trained on pretty much the entire internet's worth of historical data. So how do you test them? How can you be absolutely sure that their trading strategy is genuinely smart and not just, a really good copy of something it's already seen in the past? Well, the solution is super clever. It's something they call intelligent backtesting. Basically, they used a powerful market simulator to create brand new, completely synthetic market histories. So these are timelines that are totally fake, but, and this is the key part,
They're causally plausible. That just means the events and the price changes all make sense, like they could have happened, even though they didn't.
And this graph just shows it perfectly. That blue line, that's the actual history of the S&P 500 with all the real news events. But the orange line, that's a totally made-up timeline driven by fictional events, maybe a surprise cyber attack or a huge oil discovery. By testing the AI on both the real world and this fake one, you can really see if its strategy is robust, if it can handle a world it has never seen before.
So the big question, after all that, did it actually work? Let's take a look at the results and figure out what this could mean for the future. And the results were, frankly, pretty staggering. The trading strategies that use these new AI-discovered models consistently beat the standard AIs. We're talking better risk-adjusted returns, a higher Sharpe ratio for those who follow that. And here's the real kicker. They found that the more powerful the underlying LLM was, the better the models it discovered and the better it traded. It's a virtuous cycle.
The researchers themselves put it best in their paper. They said that model discovery, which everyone always assumed needed a huge amount of technical expertise, can be semi-automated. Think about that. A job that used to be only for super specialized financial quants can now be handed over, at least in part, to an AI.
So the really big takeaway here isn't just that this is a better way to trade stocks. It's much deeper than that. This is about a fundamental shift in what AI is capable of. It's evolving from being a simple tool user, an analyst, into an autonomous tool builder, an architect who can design and build its own tools from scratch.
And that leaves us with a massive question, doesn't it? We just saw this happen in finance, a hugely complex field. But this core ability to have an AI discover the fundamental models of any system, that could be applied almost anywhere. So the real question isn't just what industry is next, it's what industry isn't. It feels like the age of the AI architect might just be getting started.